All right, so for graphing linear equations and inequalities. First of all, let's talk about domain and range for linear equations. Just a little review. No matter what your line looks like, right? If positive slope, negative slope, doesn't matter. No matter what your line looks like, how far left are we going?
All the way.
All the way. So negative infinity. How far right are we going?
All the way.
All the way. So no matter what kind of line you have, negative slope, positive slope, your domain is going from negative infinity to infinity. And then if you put it in set builder, you're using all the real numbers. Okay, range is down to up. So no matter what kind of line you have, how far down are you going? And how far up? Right. So if I ask you for domain or range for a linear graph, everybody should get it right because it is all the real numbers, no matter what.
Are we only doing linear for like the 6 weeks? Or like
For this unit, it's just linear. This is like your linear unit. The next unit will be your absolute value unit, and then your quadratic unit, and then your cubic unit. Make sense?
yeah, I know you can.
So this is your linear unit. Alright, so these are in slope-intercept form. Alright, slope-intercept. The second number is your y-intercept. That is where you're going to start. Alright, that's where you're going to start your graph. So on the y-axis, we're going to start at 1. So I'll put a point at 1. The number with the x, that is your slope. And we're going to rise over run. Right? Rise over run. If your slope is negative, you go down. If your slope is positive, you go up. Right? And then always go to the right. So from your starting point, I'm going to rise 2. So 1, 2. And I'm going to run 3. 1, 2, 3. Put another point. If you want to put more points, you can. Rise 2. Run 3. Put another point. You can also go the other way. Down 2. Left 3. And draw a line. Make sense? Okay. Number 2. Alright, on number 2, Anaya, where am I going to start my graph? At 0, right? Because there's no number there. So I'm going to start at 0. And Noah, what's my slope?
Wait, what?
What's my slope?
4.
Negative 4 over 5. So from your starting point, you are going to, am I going to go up or down, Annalie?
Down.
Down, very good. Down how many?
Are you not doing
4.
Because I'm doing this one. This is my slope. So you start at 0, 0, because you don't have any b value, right? Does that make sense?
Are you not doing 6 anymore?
I just call on people. 1, 2, 3, 4. So down 4 over 5. 1, 2, 3, 4, 5. And put another point.
Wait. It's not negative 4 and negative 5.
There's only one negative.
Why?
Down 4 over 5. And then draw your line.
How can you tell which one's negative? You know, why isn't the 5 negative?
It doesn't matter which one's negative. We get the same answer. So if you only have one negative, right? So if it's negative, go down and then always go to the right. If it's positive, go up, go to the right. You won't have 2 negatives because what do 2 negatives make? Positive. So it's either positive or 1 negative. All right. Any other questions? All right, go down to number 3. Okay, so on number 3, it's not solve for y. So you have to get y by itself, which is what we did yesterday, which is how yesterday leads into today, is I need to get y by itself. So I'm going to draw my little line. And I want to get rid of all of the stuff over here that's with the y. Very good. Add 4x. Okay, can you combine 4x and negative 3? So, yeah. So you can't combine them. They're not like terms. So just write 4x minus 3. Y is not by itself yet. What's the last step? Right, divide by negative 1. Divide by negative 1.
Where'd you get 1?
There's an understood 1 in front of the y. Like this number right here. Alright, so that goes away. So now y is by itself. 4 divided by negative 1 is negative 4x. Plus 3. Yep. Bless you. Okay, now you can graph it. You're going to start at 3. Because starting value. And your slope is negative 4. So from your starting point, you're going to go down 4 because it's negative and over 1. All right, any questions? That I divided by?
Yeah.
There's an understood 1 in front of the y.
Is that one like the equivalent of y? Yeah, I do it 2 y. How can you divide by 4x if it's negative 3 and negative 3x?
I'm not dividing by 4x, I'm adding it.
Oh. I thought you can only
Just
do
say
that
stalls room.
if they have like terms, or like if they both have x.
You can combine them if they both have x, but since the 3 doesn't have an x, you would just write 4x minus 3. Are you leaving?
No, I'm just gotta get.
Here, look, take a pass.
She said it's coming back, just left us on.
Yep.
All right, on number 4. So, similar problem. I have to solve for y. So, Emily, what's my first step? Oh, I said Emily, but yes, you're right. Negative 2x. So, I'm going to add 2x to get rid of that. Okay, Emily, can I combine negative 10 and 2x together? No. Okay. No one answered but Emily. Emily, what is my next step? Very good. Divide by 5. So we're going to divide everything by 5. So I just have y on that side. Over here. 2/5 x. And then what is 10 divided by 5? Negative 2. You're good. So start at negative 2. And you go up 2 over 5. Up 2 over 5.
Is this how it always is? Is it this simple?
For linears, yeah. Alright, turn it over on the back.
If you're done with checking, we have to check this.
Alright. Part B, graphing special lines. So this is going to be just like graphing your asymptotes. Just like graphing your asymptotes. So you have x equals a number, and you have y equals a number. Alright, so let's do the x one first. On the x-axis, find 4 and put a point. Because x equals 4. So find on the x-axis 4, and we are just drawing a straight line through 4. Is it going to be horizontal or vertical?
Vertical.
Vertical, very good. No, vertical's right, sorry. I was just making sure. Vertical, so you're going to have a vertical line straight through 4. Because you are going through the x-axis.
Hey, I sure some this morning. And then you just plot the -3.
Yep, and so then plot the -3. Now is this one going to be vertical or horizontal? Horizontal, very good.
So this one chances on.
This and everything else we've done for Unit 2. Everything we've done this week. Alright, next one, number 6. X equals -5 and y equals 2. So on the x-axis, find -5. And you're going to draw a line through it. On the y, find 2. And draw a line through it. So it's just like your asymptotes, but we actually have a line instead of a dotted boundary. Right, but you graph them the same way we did the asymptotes.
Can we have a test on GP?
No, well, this is on your test. It's not just this, but
Well, at least one some questions.
there's 2 questions on your test that are graphing. All right, graphing linear inequalities. Linear inequalities. Same thing as with the lines, but you got to remember 2 things.
Wait.
1, is your line solid or dotted? And 2, are you going to shade up or down? So, first, if you have the little inequality bar, underneath your sign,
That's the line, right?
is it solid or dotted?
Solid.
Raise your hand for solid. Raise your hand for dotted. It's solid.
Yeah.
It's solid. So if you have the line, it's solid. So the line is going to be a line. If you don't have the line, it's dotted.
Because that's supposed to show that it's not included, right?
Correct. Dotted shows that it's not included. Solid shows that it is included. All right, so let's graph number 7. All right, so number 7, where am I going to start?
-2.
At -3, right? That guy right there? So on your graph, put a point at -3. What is your slope? 1/2. So go up 1/2. And is it solid or dotted?
Dotted. No, solid.
Solid because of that bar right there. So solid line. Bless you. All right, so now I need to know if I want to shade above or below. So this is the sign that I have, right? Is that a less than or greater than sign? Less than sign. So am I going to shade above or below? Below. All right, so how you can tell whether or not it's a less than sign? If you kind of see, can you see how you can make an L with it?
Yeah.
Like if you just stood it up a little bit, it'd be an L. L less than. Make sense?
I thought it's less than if it's facing. It has to be less, like y has to be less than. Is that how you know?
Mm-hmm.
So if it was facing the other way, it'd be above.
Wait,
Yep.
is that -3 in X or Y?
Oh, yeah.
A Y intercept.
Oh,
It's solid.
All right, so then this other question here, it says, is 3, 4 a solution? So 3, 4 is this point right here. Is that a solution? Why not? Right, it's not in the shaded region. What if the point was on the solid line? Would it be a solution?
Yeah.
What if it was on a dotted line?
No.
No. Very good. All right, let's do number 8 and then we're done. All right, number 8, we have to solve. We have to solve. So, Nathaniel, what's my first step? Right, move the 3x. So I'm going to add 3x, add 3x. 7, what's my next step?
Divide by 1.
Not just 1.
Negative.
Yes. Divide by -1, divide by -1, divide by -1. Who remembers something that I have to
Flip
do?
it.
Very good. Flip it. So, when
When
you
you're dividing by that negative, you have to flip the sign.
Mhm.
But,
No, flip the inequality sign.
yeah, flip the inequality sign. See, it doesn't work with equal sign because it just
Stays equal. So anytime you divide or multiply by a negative number, only multiplying or dividing, this inequality sign has to be flipped. So instead of it being greater than, we're going to flip it and make it a less than.
So if you divide by a positive 1.
Doesn't change.
only negative.
So only negatives. Yeah, that's the biggest mistake for these inequalities that people forget. All right, so then this is going to become a negative 3x. 3 divided by -1. Negative 3 divided by -1 will be a positive 3. So we'll start at 3. Down 3 over 1. Down 3 over 1. Is it a solid or a dotted line? Solid. And am I shading above or below?
Below.
Below, because it's less than. All right, and then last question, Vivica, is -4 a solution? It's right there. Yes, it is. Very good.
Yeah, I got a question.
What's up?
Say on those, you don't know what is above or below.
Yeah, how you know?
Yeah, how do you know if it's like above or below? Yeah, that is
Because
kind
it's
of
side
tricky.
to side.
So if you had a guy and he was like walking up a hill, right? That's above. You see, he can't walk below down here. It wouldn't make sense. He'd fall down. So it's like, think of a guy or an ant walking on it. And see right here, this guy's walking on it right here.
Yeah.
So that would be above, but he can't walk. You can't draw a stick figure and walk him below. Another way to think about it, the more mathy way, is you're using the values below, so the y values that are less
Then 3.
than 3, yeah, and then these are the y values greater than 3. So this is above, that's below. So whichever way makes more sense.